Learn it fast, learn it smart, learn with us at Sofo. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to concept videos from Sofo Learning. Today we are going to focus on degree and zero of a polynomial. Now the kind of polynomials that we will review today are with single variables, meaning there would be only one single variable, let's say x, in that entire polynomial. Now what is the degree of any polynomial? Degree is defined as the highest power or exponent of the variable available in that polynomial. Now let's imagine a couple of examples. Let's say our polynomial is x minus 4. Now this is the variable and the highest power is essentially 1. So the degree of this polynomial is 1. Now let's think about root 3x squared minus x plus 20. Now the highest power or the highest exponent is for this term and 2 is the power, therefore the degree of this polynomial is 2. Let's kind of do one more. Let's say root x minus 5. Now we should know that this is not a polynomial form because it doesn't follow the standard the standard form of the polynomial. So this theory doesn't apply here. Now this, as you know, is a linear polynomial because the degree is 1. This is called a quadratic polynomial because the degree is 2. Now we're going to see other polynomials, one more type of polynomial which is called cubic, where the degree would be 3. So there you have it. That is our introduction to how we identify the degree by looking at the highest power or the highest exponent. Now let's think about how do we evaluate a polynomial. So let's take an actual example. Let's say p of x, which is our polynomial with the variable x, is x squared minus 5x plus 7. Alright, now if we want to apply or evaluate this polynomial at value x equal to k, then we replace x with k. So this means we're going to look at k squared minus 5 times k plus 7. Now if we want to evaluate x equal to, let's say, 10, then we would do 10 squared minus 5 times 10 plus 7. If we want to do x equal to negative 12, then we simply apply that negative 12 minus 5 times negative 12 plus 7. So this is how the application works for evaluating the polynomial. We simply apply the variable, we simply replace the variable with its value. Now a very special case of evaluating the polynomial is called the zero of a polynomial. Now we should understand this as the place where this polynomial p of x is equal to 0, not where this variable is equal to 0. Now let's imagine the zero of this particular p of x is that this entire thing is equal to 0. Now we can find values of x where this p of x equal to 0, but this is the concept where the p of x becomes 0. Now we will look at how this p of x looks on a graph and what is the significance of its value p of x being 0 on the graph, but you should understand the concept as the entire polynomial is evaluated to a value of 0, and that's called the zero of the polynomial. Next, we're going to evaluate and study the relationship between the degree of a polynomial and the zeros of a polynomial. All right. Now, we're going to study that. We're going to look at a system of graphs of a number of polynomials in different degrees, 1, 2, 3, etc., in order to understand this concept. But before that, let me just show you the concept that the degree is equal to the max number of zeros. So if you have a polynomial of degree 1, then the maximum number of zeros would be only 1. If you have a degree 2, which is a quadratic equation, the maximum number of zeros would be 2. If you have a cubic polynomial, then the maximum number of zeros is 3. So we are going to look at these 3 scenarios next. I have graphed a linear equation, which is basically degree 1 equation, 3 different types of equations here. And what I want to demonstrate is that there is only one single zero possible here. So the x-axis is the x value and the y-axis is the p of x value. Now, as you can see, the value of p of x basically reduces and it becomes 0 at this point, at this point, and at this point. And you can see whichever way we draw this, in this direction or in this direction or in this direction, we're going to get only one single zero possible here. Here is the next scenario that we really want to look at, and we have 3 different cases of a quadratic equation here. And quadratic equations have a degree of 2, and as you can see, the maximum possible zeros is essentially 2 here as well as here, and you have two of them here. Now this is a case where there is no zero. The graph simply doesn't touch the zero here, and it touches just a single time, so there is only one zero here. So there is 1 0 here, there are 2 0 here, and there are 0 zeros here. So this is the max possible zero. All right, so that is the case of a quadratic equation. We are again proving that the max possible zero is equal to the degree of that polynomial. All right, and here is the final scenario that I want to show you. We have a cubic polynomial with a degree 3, 3 different cases of a cubic polynomial described here. And as you can see here in this graph, right, it meets the 0, it becomes 0 at 3 different places. All right. Now here you have a case of 1 single zero, and here you have a case of 2 zeros, but the max case is 3. So let me recap the key points here. Okay, so first is that the degree of a polynomial is the max exponent or power of the variable in that polynomial. Second is that if the degree is 1, if the degree is equal to 1, then we have a linear polynomial. If the degree is 2, you have a quadratic polynomial, and if the degree is 3, you have a cubic polynomial. The zero of a polynomial is when the polynomial p of x is equal to 0 and the max number of zeros is the degree of the polynomial. Thank you very much.